Woohoo, we're live. This is Math 60, Intermediate Algebra, and we are in section 7.7, which is the set of complex numbers. We're in the middle of a lot of weirdness. Things are likely to get a lot weirder before they get less weird. So, woohoo, let's soldier on, or mathematician on. Okay, so number 5 asks us, so can you add and subtract complex numbers? Well, of course you can add and subtract complex numbers. If I've got 4 plus 3i, and then again, handy dandy highlighter, there's a negative here, so minus 6, and then plus I. Notice that? So subtraction works exactly the same way. You're going to add and subtract these just like you would add and subtract polynomials. Just instead of an x, you've got an I. But remember, I stands for a number, not a variable. So I've got 4 minus 6 plus 3i plus I. So I get negative 2 plus 4i. Woohoo. Next up, can you multiply complex numbers? But of course you can. Okay, so I've got radical negative 4, radical 25, radical negative 4, 2i, radical 25, 5. 2i times 5 is 10i. Again, addition, subtraction, multiplication all work exactly as if you were using an x. So just like this is a polynomial, except we're using i's instead of x's. Next question, well, what if I put a minus on the outside? Will that fix the minus on the inside? No, siree, Bob. So the minus on the outside and the minus on the inside satisfy far different purposes. So, okay, let's see if we can keep it from smearing. The minus on the outside, that's smeary, and the minus on the inside, tells us that we've got 2i. So the minus on the inside gave us the I. Not sure if that's entirely visible. And the minus on the outside changes the sign. So we get negative 2i, the opposite of 2i. Kind of woohoo. Oh, I forgot to box these. Happy little boxes. We'll put happy little boxes everywhere over our paper. Okay, next question. Well, can I fix a complex number by multiplying by another complex number? And a lot of people would say negative 4 inside a radical times negative 25 inside a radical. That should be negative 4 times negative 25 inside, which should give us a positive 100, which gives us 10, right? And I'm going to find my red pen and say, no, nuggety, 9, no, no, no. Is that enough red for you? And it's kind of a long story and it's kind of a short story. And if there are no mathematicians around, I can tell you something that's not quite right, but is close to right. And that is that a minus inside is like the square root of a minus. I mean, it is the square root of a minus. So the square root of a minus times the square root of a minus gives you a full minus. So what the heck does that mean? Well, let me try this. Square root, or radical negative 4, is 2i. Radical negative 25 is 5i. 2i times 5i is 10i squared, which is 10 times negative 1, right? I squared is negative 1. 10 times negative 1 is negative 10. Woohoo? I hope it's kind of woohoo. So if you multiply two square roots of negative numbers, you end up with a negative number. It's kind of interesting. This is a weird new world. Complex numbers are really different. Now, hopefully you notice these are not just a product of two binomials, but you notice the pattern a plus b, a minus b. That's kind of interesting. So you can either use the fact that this is going to be a difference of squares, or you can go ahead. I'm just going to FOIL. So first is 2 times 2. Outer is minus 2 times 3i. Inner is plus 3i times 2. And last is minus 3i times 3i. So I get 4 minus 6i plus 6i minus 9i squared. The two middle terms cancel out, like we know, because this is going to be an a squared minus b squared situation. What is I squared equal to? You're right. I squared is equal to a negative 1. And something miraculous happens. We have an a squared minus b squared situation, but b squared is negative. So we get 4 plus 9, which is 13, which is truly weird. So the note here, numbers like those in number 9, these are of the form a plus bi and a minus bi are called conjugates. Conjugate means they go together. Mathematicians love conjugates. And then you're going to say to me, but why would we ever use a conjugate? What is that useful for? And I just say, I'm so glad you asked, but you're probably going to regret it. Okay, but no, knowledge is always a good thing, even if it hurts a little bit, right? Complex numbers in the denominator. Remember when the worst thing in the world was rationalizing the denominator? Well, now we're going to have to realize the denominator. We have to make the denominator real. So we're going to simplify fractions with complex numbers in the denominator. This is some weird stuff, I gotta tell you. This is some weird stuff. So I've got the number 7 plus 4i in the numerator. I've got 5i in the denominator. The number 5i equals 0 plus 5i. The conjugate of that number is 0 minus 5i. So, which is basically just the opposite of 5i. So the conjugate, if there's no real part, you just take the opposite. So I'm going to take the 7 plus 4i all over 5i, and I'm going to multiply by the opposite of 5i, top and bottom. I know, super fun, right? So I get negative 35i minus 20i squared. And downstairs, I'm going to get negative 25i squared. And then I'm going to say to myself, okay, but I've got an I squared here. So this is going to be a negative 1. And down in the denominator, same thing. So I get negative 35i plus 20 all over 25, which I can then write as 20 minus 35i, each of them over 25. But wait, there's more. I can reduce these. And get that. Whoa, I know, mind blown. And so you're going to ask me, seriously, you're going to look at this and you're going to tell me that this is better. And I'm going to say yes, much. This is in the form of a complex number. This is a mess. This is beautiful. This is a mess. Believe it or not. And I know if you're just starting out, you're looking at that saying, this is ridiculous. Why are you making us do this? And the answer is because some of you will need to use this. Some of the most interesting math in the universe is being done with complex numbers. Believe it or not, even though I stands for imaginary, this engineers use complex numbers to study circuit design. There's a lot of other really wonderful things being done with them, hardware and software. So it's really worthwhile to understand this at least a little bit, especially those of you who are going on to calculus. So, do you have to be this fancy? No. You could, in this case, multiply, because the denominator is a simple 5i, it just has an imaginary part. You could have multiplied top and bottom by I and simplified that, and you would get to this eventually. So you don't have to use exactly the conjugate in this case, but in this case, down there in number 2, you absolutely have to. It's going to be your only saving grace. So if there's an I in the denominator, you need to put your I out. Okay. Sorry, no Oedipus jokes? No, okay. So I'm going to look at the denominator, and I'm going to see 1 minus 5i. So I'm going to say, oh, I need to find 1 plus 5i. I need to use that to simplify this. 7 plus 4i all over 1 minus 5i times 1 plus 5i all over 1 plus 5i. You can either FOIL this, or you can multiply out a different way. This is always going to be that a squared minus b squared, but again, I'll FOIL it to show you. So I've got 7 times 1 plus 7 times 5i plus 4i times 1 plus 4i times 5i. Sorry, it got tiny there. And then down here, I get 1 times 1 plus 1 times 5i minus 5i times 1 minus 5i times 5i. Let me write that out again. 7 times 1 plus 7 times 5i plus 4i times 1 plus 4i times 5i. 1 times 1 plus 1 times 5i. Oops, sorry, that should be times, sorry. My hand wanted to write plus. Minus 5i times 1 minus 5i times 5i. Now you can see when we really get going how important it is to make sure your i's do not look like ones. So up top, I've got 7 plus 35i plus 4i plus 20i squared all over 1 plus 5i minus 5i minus 25i squared. Remember that I squareds are not actually imaginary. They're real. So this I squared right here turns into that minus sign. And this I squared right here turns into this plus. These two in the denominator cancel out because of the a squared minus b squared. That's why we want to use the conjugate. Right up here, we figure out if we had 1 minus 5i, we multiply by 1 plus 5i. And that's what helps us cancel out these i's in the denominator. So we end up with just real numbers. We get the 1, and then this becomes not minus 25, but plus 25. Also here, 35 and 4, that gives me the 39i. But this I squared makes this a minus 20. So up on top, I get negative 13 plus 39i all over 26, and I split it up. Negative 13 over 26 plus 39 over 26i. See me doing that? I split this up over the 26. 13 goes into 26. It's negative 1/2 plus 3/2 I. And you did it. We got through it. Chapter 7 is done. Now you just have to do all the homework. And I will see you again in a little bit with Chapter 8. Woohoo! Math on. Yay!